Okay, this is the last one I'm giving you on base theorem. I like this one, and I would definitely review this when you get to exam one. And again, here's another Bayes approach. So again, I'm going to go ahead and write my columns, my tables. We're going to have a prior probability. That's going to be my margins. We're going to have our condition. I'm going to write that column right there. We're going to have our joint probability. And then finally, we're going to have our posterior probability. Okay. Now remember, your margins have to equal 1. Now, in this particular problem, we're only going to have two events. We're going to label these as A1 and A2. And up at the top, just to remind you, A1, when you read through it, it's going to be the probability that a customer defaults, and A2 is going to be the probability that they do not default. And so as you read the problem, it says 5% of cardholders defaulted, so that's going to be one margin. And then the other one's going to be the complement. If 5% default, then 95% do not default. And so there's my two margins, okay? Now, the B event here is going to be, I'm going to write this right here, is missing a payment, missing one of the payments. Now, they tell you that, notice up here it says prior probability of 0.05 that any particular cardholder will default. So again, they're kind of giving you that that's the first prior, but I just went ahead and plugged it in for you. But notice it says the bank found that the probability of missing a monthly payment is 0.20 for customers who do not default. So I'm going to put that condition right there. So that's, somebody missed a payment. They're not defaulting, but they may have just paid it late, but they actually missed one payment. I'm going to put that right there. Now they tell you in the very last sentence, it says, of course, the probability of missing a monthly payment for those who default is 1 or 100%. I'm going to put that right there. But if you think about it, they didn't really even have to tell you that. If you kind of read into conditional probability, this says B given A. Think about the logic here. If a customer is defaulting, that's basically by definition, they're not making payments. So this 1 is basically an implied number. But in this case, they went ahead, that's why they said, of course, it's got to be 1. But I want you to think about the logic there. Think about it. If they are missing a payment, they are defaulting. Okay, I'm sorry. Let me go back. If they're defaulting, they're missing a payment. So this 1 is basically an implied probability. So that even though they gave it to you, let's say they didn't tell you that, that's something you might be able to have to still figure out. Now, like I said before, now you got the first two columns, and then it's pretty simple at this point. What you have to do then, I'm going to again label this again, there's your intersection, is you're going to have to multiply. So 0.05 multiplied by 1 obviously is 0.05. And again, as long as you label these and set these up, it should make it easy for you. When you take 0.20 and multiply by 0.95, you get 0.19. So I'm going to put that right there. And then, of course, add these down, you get what, 0.24. And then your last step would be to take 0.05, divide that by 0.24, and 0.19, divide that by 0.24. And so see 0.19 divided by 0.24 gives you what, about 0.79. That's going to go about right there. And 0.05 divided by 0.24 is going to give you about 0.21. And of course, notice that does add up to 1. Here's your probability of A given B. So now you can say, if it flips, given somebody's missing a payment, what's the probability they're going to default? It's actually about 21%. So when you look at the requirements of the problem, not obviously says compute the posterior probability that the customer will default. These are all your posteriors. The answer is 0.21. And of course, is the bank going to recall the card? If it's, and it says if it's more than 0.20, they will. So in this case, you would say, yeah, they're probably going to revoke the card because this, according to the Bayes theorem application, they're at a greater risk of defaulting. It's more than that 0.20 because it turns out to actually be 0.21. But again, this is just like the other illustrations. If you notice some repetition here, put it in a table, and trust me, once you get to an exam, I'll tell you, I'll help you out. I'll tell you it's Bayes theorem. So I'll take that guessing game out of it. And then hopefully what you'll have to practice is setting the numbers up in these tables. And typically the goal is to get to the posterior probabilities.